Hello friends, in this problem you have a factorial equation that also includes exponential terms. So the equation is you have x factorial raised to the power x and this is equals to x factorial. So what is the value of x that satisfies this equation? Now to solve this problem you need to know what is factorial. So if I say x factorial, this means x times x minus 1 times x minus 2 times x minus 3 and this goes on to 3 to 1. Now you can solve this problem by taking log. But before that, let us discuss what is domain of x in case of x factorial. So we have x factorial here. So what is the possible domain for x? So domain for x is factorial is defined only if x is greater than or equal to 0 and also x should be whole number. It should be 0, 1, 2, 3, something like this. So discrete points. So factorial function is defined only for discrete positive points. So now let us take log both sides. So we will have log of x factorial raised to the power x and this side log of x factorial. Now the property of log, this says if we have log of a raised to the power m, this can be written as m times log of a. So with this property I can write x times log of x factorial, this is equals to log of x factorial. Now let us take this term to the left hand side. Then we can write x times log of x factorial minus log of x factorial and this is equals to 0. Now you can take log of x factorial common. So this becomes x minus 1 is equals to 0. So now you have two possibilities. Either this term is 0 or this term is 0. So if you have log of x factorial is 0, this means x factorial is 1. So this is x factorial is equals to 10 raised to the power 0 and this is 1. Now x factorial is 1 only if either x equals to 0 or x is equals to 1, or if x minus 1 is equals to 0, in that case also x is equals to 1. So you have two possible solutions, that is x equals to 0 or x is equals to 1. Now you can also solve this problem simply by algebra. So we can have an alternative method. So let us discuss that method also. So you can have an alternative method. So the initial problem is x factorial raised to the power x is equals to x factorial. Now let us divide both sides by x factorial. So if I divide both sides by x factorial, this side will be same, but the right hand side will be 1. Now see, base is same. Here base is x factorial and here base is x factorial. Base is same. So now if you have something like this, a raised to the power m divided by a raised to the power n, then using rules of power you can write a raised to the power m minus n. So this means I can write x factorial raised to the power x minus 1 is equals to 1. Now analyze this term, that is x minus 1, x factorial raised to the power x minus 1 is equals to 1. So this 1, so how we can have 1 from this term? So different possibility we can have. First possibility is x factorial is equals to 1 and x minus 1 is real number. Of course, x minus 1 belongs to real number, that is x belongs to real number. This means if we have x factorial is 1, so any power of 1 is 1. So in this case, if x factorial is 1, this means x equals to 0 or x is equals to 1. Now the second possibility is you have x factorial here and then x minus 1. If this becomes 0 and base can be anything, of course it should not be equal to 0. Then if base is anything not equal to 0, then if you raise power 0, then this becomes 1. So in this case also this will satisfy the original equation. So this means in this case x minus 1 is equals to 0. This means x is equals to 1 and also x factorial should not be equal to 0. And this is true because factorial is never 0. So this is always satisfied. That is x factorial is not equal to 0. This is always satisfied. So in this case, I get a solution x equals to 1. Now we can also have another possibility, that is this becomes negative 1 and this becomes an even number. In that case also, this will be equal to 1. But x factorial is negative 1. This is not possible because, so what we are saying is, in this case you need to have x factorial is equals to minus 1, which is not possible. Factorial can be 0, 1, 2. Minimum value of x factorial is 0. So it can never be negative. So this is not possible. So in this case also, from this method also, we get a solution x equals to 0, 1. From this part I get a solution 1. So basically in this case I can say x is equals to either 0 or 1. That is the value from the previous method. So I hope you enjoyed this video, and if you enjoy, please share with your friends, like this video and subscribe to my channel. Thanks for watching this video, and I will see you in the next video.